All right, I think we're up and running. Okay. Um, I don't have anything specific to talk about, but if you have questions, put them in the chat. I think I see where that is. Um, yeah. So I realized I didn't cover the statistics portion that we did. So I'll go chapter 0, stat and probability re-review. And there's an echo in here somewhere. Okay. Uh, Turn that off. Okay. So we have chapter 0, review the stat and probability. We had 7 vocab words that were important. We had mean, median, and mode. That's sort of the first 3. Then we have another 3 that is range, variance, and standard deviation. And the last one is quartile. So these were the 3 vocab words we went over in chapter 0. We had our mean. That was just we'll change colors. That was just our average. I'm going to show you how to get all of these on your calculator. We have median. That's our middle value. But if we don't have one middle value, that's going to be the average of our 2 middle values. We have the mode. That is our most common. So if a number occurs the most number of times, that is our mode. Our range is our biggest minus our smallest number. Variance and standard deviation are the ones that are a little more complicated. We have, what is a good definition for variance? We'll use this. How about the average of the squared differences from the mean. So the variance, once again, it doesn't have really any relevance to it. It doesn't have any units. It's just a measure of how spread out our data are. Standard deviation, on the other hand, that is the square root of the variance. Lastly, quartile divides our data into about groups of 25%. So these are sort of our 7 big ideas we talked about in 09. And then I want to do a quick example and show you how we get this kind of stuff on your calculator. If you have specific questions, put them in the chat. I will see if I can do something about that. Someone says piecewise functions. Someone says we need a face cam. We might have to kick him out. Can you put symbols of the vocab? Oh, yeah. So our mean has sort of a couple different symbols. We have this X with a line over it. Or, what was it? Yeah, I don't even remember anymore. So, needless to say, that's not going to be important. This will show back up on the calculator. Standard deviation on calculator, we want SX. Standard deviation, we want SX. Quartile is Q1, Q2, Q3. And I'll show you how to get all three of these on the calculator. So, taking these, get a little example. So, we have an example where we have a couple numbers, 28, 35, 21, 37, 42, 50, and 25. We're going to take these numbers and plug them into our calculator and get all this data. So, pay attention now so we don't have to do this tomorrow because I'm not going to want to. In our calculator, we can put this data in under stats, edit, and then we have L1. So we have these three numbers. We're going to put these in our calculator. To get rid of the values in here, we just press delete. Don't press clear. Clear does nothing. You're going to need to delete each of these. If for some reason you come up here and delete the whole L1, so now we only have L2 here, we can't get back to L1. We're going to go to Stat and Setup Editor. That'll bring it back, L1 back to us. So if you ever delete L1, you can get that back with Setup Editor. So once we have L1 clear, we're going to put each of these in: 28, 35, 21, 37, 42, 50, and 25. So we have seven things, 7 numbers. Make sure we have them all in. The worst way to lose points would be to not put them in correctly. So make sure you do that right. Once we go there, we press Stat again. Go to Calc, and we want the first one, 1 var stats. And we run it, and we get a couple things. First thing we get is our mean is 34. Our SX is 10.13. That's our standard deviation. We don't want the sigma. Our min is 21. Q1, 25. Median, 35. Q3, 42. And finally, we can call this Q4 or max. Ignore that. Q4 or max is going to be 50. So we went through, put in L1. That's our 5-number summary. The minimum, Q1, median, or Q2. It's the same thing, Q3, and then our max. That's our 5-number summary. We put it in. We get all this from our calculator. Our mean is our X with a bar over it. So that's sort of the quick review of what we did in 09. Let's look at see what people are saying. Goodroe was probably you showing up at the exam. Probably 0%. Everett says, "What is up, everybody?" That's great. What's a question that UD use this for? How do you find the variance? The variance, we can find the variance with our standard deviation. It's going to be 10.13 squared. So that'll be 10.13 squared. And that is roughly equal to 102.62. So a couple questions, I could give you this sort of data and say, give me the 5-number summary, and this could be what I'm looking for. I could say, what is the variance of this data? And you could give me this. So there's a lot of stuff that you can use this for, and I can ask from this. But it's pretty easy. Once you just know how to put it in your calculator, you'll get the kind of answers you want. I want to do one more probability one that I think will be like what you'll see. Once again, if you miss all this, it is on YouTube and you can go back. So we're going to make a probability question where we have these marbles. We need one more color. Let's do pink. So probability of pink. All right, so we have these 9 marbles here. We have 4 pink ones, 2 kind of green ones, 3 orange ones. Let's say I take 2 of them out. Without replacing. What's the probability I get a pink and a green one? So once again, I have this bag of marbles. We have 4 pink ones, 2 green ones, and 3 orange ones. What's the probability? When I take 2 out of there, I get a pink and a green one. So a couple things to note. We have 2 picks. And it doesn't matter if we get a pink first or a green first. It's going to even out the same. So let's just say we'll get a pink first, and this is scenario, then green. So the odds I get a pink from here is 4 out of 9. So I have 4 chances to get a pink out of 9. This is an AND problem, so that means I'm going to multiply. That means we're going to multiply our first pick from our second one. So green, I have 2 green that I can pick from, but I've already taken 1 out. So in theory, that's gone. So now I have 8 to pick from, and so I'll multiply them. So I have 8 over 72, which is going to simplify to 1/9, or 0.12, or 1/1. Let's just say 1/1. So we have a AND problem where we have a pool of things, and we're taking things out, and we're not replacing them. We're taking things out, not replacing them. We calculate the probability by multiplying the first one and the second one. So this is sort of after we took 1 out. That's the big thing. So those are the things we need to remember from chapter 0. Lots of things about piecewise functions, so we'll go over that in a second. Graphing system inequalities, linear programming. Yes, okay. So let's do piecewise real quick. Yeah, we'll do piecewise and then we'll do linear programming. Remember, piecewise is only going to be 1 question. So if you don't know it, it's okay. Life goes on. F of x is going to equal now 3 things. How about 2x, 3, and negative x plus 1, x less than negative 2, negative 2x, and then let's say 3, then x is bigger than or equal to 3. All right. Probability, you just decimal or fraction will be fine. Decimal fraction will be fine. That's one of the questions. So we have this piecewise function. We have 3 different graphs we're going to chop up and put together. I'm actually going to show you this on Desmos real quick. So hang tight. Let's switch over there. Oh, here we go. So I have three functions, y equals 2x. I have y equals 3, and I have y equals negative x plus 1. So I have three different functions. I have my red is my first one, my blue is my second one, and my green is my last one. So what piecewise functions are doing is saying we have these functions, but we don't want them everywhere. Like we want this blue one maybe to the left of this, or this green one in between here. So what we're going to do is chop these three up and show you what we're looking for. So I will type this into Desmos. It's a little complicated. Don't worry about this formatting. We have x, oops, x less than negative 2, 2x, okay. So what I'm doing right now is putting them into Desmos to show you where we get them and sort of how we put them all together. And I'll show you each piece being cut up. And lastly, we have x is bigger than or equal to 3, comma, and our function is negative x plus 1. Not comma, that should be a colon. Okay, so let's get rid of this. Our first function we have is y equals 2x. If you look back here, you can see that's our first function. If we just rewrote this as y equals 2x, but only where x is less than negative 2. That's what this first line is saying. So we come up here to Desmos. This is y equals 2x. It's got a slope of, a y-intercept of 0 technically, and a slope of 2, so it goes up 2 over 1 every time. But we're saying we only want this where x is less than negative 2. So let's see if I can do this actually. Y, so I only want it, this is my graph, I only want it left of this negative 2. Here's my regular graph. And what we're saying is we want it to the left of negative 2. Okay, that's our first one. Our second one right here, that's going to be y equals 3, but only between negative 2 and 3. So we have y equals 3, but only between this. Y equals 3 is going to be our constant graph. Y equals 3 is going to be our horizontal graph going across. It's a constant, it has no slope. And so what we want is this graph, but we only want it between negative 2 and 3. So put that in real quick. So we take this and we cut it up. We say we only want it between negative 2 and positive 3. So our last equation is this. We cross the graph at positive 1. We have a negative slope of negative 1, and we only want it after 3. So we put all those together, we're going to get this graph. Zoom out a little bit. So this is the first, the second, and the third. And if you want to answer this on the exam, what you need to do is look for this. Your constants are going to be your easiest thing to look for. That we know what they look like. We know they're going to have a little graph. They're going to go like this. They're going to be horizontal, flat. Knowing this and where it is your biggest clue. for piecewise functions. Once again, there's only one question on there that's going to look like this, but if you find that, if you find the constants, you'll be okay. Let's see what other questions we have. Will there be number lines in the exam? Yes. You're going to get, oh, number lines? No. There's graphing like we've had, but not number lines. What is he doing? That's what I feel like y'all ask all the time. Piecing me together? That seems like a deeper question than I have time for tonight. Linear programming, let's do that one. I don't know what this is about, but I can get subs for no reason. So probability is a matter of fraction decimal. Unbound. Can we do an unbounded finding the max and min, please? Okay. So let's do a linear programming with some simple equations. We have, let's just say y is greater than negative x. Okay, I'm going to start graphing this on my own so I can see what it's going to look like. So y. And negative x plus 1. Okay, let's do that. So with that, y is less than or equal to negative x plus 2. And then we need a function of x and y. How about 3x minus 2y? Good enough. All right, so this is going to be a bounded linear programming. And what I would do is not graph it in your calculator. I think it's going to be easier to graph it outside your calculator. It'll be easier to graph it outside your calculator and find the vertices, because we have 3 big steps we want. Step 1, we're going to graph. We're going to graph it, put it over here. Step 2, find the vertices. And the vertices are just a fancy word for the corners, places where lines meet, and then solve our equation. This solve step gets more complicated if it's unbounded. We have to find, also known as just find minimum and or maximum. So remember, we have bounded, have a minimum and a maximum. Unbounded, have a minimum or maximum. In the instructions, I'm pretty sure I left you and an or. Say, if it says or, that probably means it's unbounded. So as long as you can see this and graph it by hand, I think you'll be in a pretty good spot, and it's not too hard if you can't do that. So we'll start with this one. This one has a slope of -1 and crosses at 0. So I'm going to go down 1 over 1, or up 1 and back 1. So we're going to graph kind of like this. It'll be a little easier because you'll have the tick marks and everything. This one's going to have the same slope, slope of -1, but it crosses up here at 2. And then this one, we have x is less than, or x is greater than or equal to -2, but less than 3. What this is saying, remember x are going to be, no, they're going to be vertical lines. So we have one vertical line at -2 and one vertical line at +3. Once again, your steps are to graph it. To graph it, look at these. If they're not already in slope-intercept form, then just divide them away. There may be some stuff out here, but you just may need to divide it through. Once you graph it, especially on level people, you're going to have a shape that is a closed bounded region. This one has 4 corners. Honors, you may have some other kind, but I would use your calculator to find it. Plug these in. If you can't plug that in, you can know that this is x is gonna sit in between these two, because you can see it in between here right now. Now we have to find these points, and with a graph, it's a little easier to find them. We know we have 4 points, 1, 2, 3, 4, 1, 2, 3, 4. This one's going to be -2. This one's going to be 3, -2, and 3. This one's going to be -2, 2, and that's going to be -2, 4. This is going to be -3, and then this is going to be -1. So we graphed it, check. We did that by hand by looking at this, finding a slope, finding our intercept, drawing it, knowing that these are going to be vertical lines because they're x's, horizontal if they're y's. I probably won't even do something like this on the exam. I think I gave you what? Actually, let me check. Yeah, no vertical lines. So either horizontal or diagonal lines. We get this. And our last one is to solve. So what I'm going to do is I'm going to put each of these into this equation and see what I get. I will just put it through my calculator. So I have -2 times 3 minus 2 times 2. That's -10. Okay, 3 times 3 times, no, minus 2. That gives me 15. 3 times -2 minus 2 times 4. That gives me -14. And lastly, 3 times 3 minus 2 times -1. That's 11. So these go in order, so this matches with this matches with this. Obviously, you'll have a little more room and be a little neater. So we have a maximum value. Our biggest output is coming from this one. And our minimum value is our smallest output, and that's coming from this one. And that's really all I need to know. I mean, even something like this, I'll be like, oh, great, he has the 3 things, the points, the graph. This is everything you need. So go slow. This is going to be on it. I'll just tell you that right now. But it should be easy. It's not meant to trip you up. It's just meant to show you there are the steps to go through. You have to graph it, find your vertices, and solve. If you do these 3 steps, even if they're a little wrong, you'll get most of the points. All right, let's see what else we'll get. A lot of stuff. Sparrows went away. I don't know what that means. Piecewise on the calculator. So can we do piecewise on calculators and it'll give us the answer? Yeah, like I said about piecewise, the important thing to look for are going to be the constants. So look for the constants, and that'll help you identify which of the options is correct. Completing the square and vertex form, would there be filled in dots and not at the second equation in the list? Yes, we didn't go over that, but yes. Equal to have filled in, not equal to have dotted. I'll go over completing the square and vertex form in a second. Identity matrix graphing inequalities. How many questions are on the exam about the bounded and unbounded stuff? 1, so 5 points. Are you going to give us graphs to write on, or do we have to make our own? I will give you graphs. They're not going to be huge, but they'll just be normal sized. I think they're 6 by 6. So if you have a graph that goes off the 6 by 6, then you know you did something wrong. So it is designed to be the right size. So we don't, you don't get graph paper. You could bring graph paper if you want, but I will give you a graph to do the stuff on. All right, we have a question from Honors about vertex form, so I'll jump into that. Vertex form. I'll put Honors over here so none of my on-level people freak out. Can we come in early? I suppose you can come in early. I don't know if I'll be there, but you can come in early. What other things do we see? Cole Smith. Can you show how to find the root? Yep. How do you find the inverse of matrices? Okay, perfect. So we'll do this. Let me make a little, I'll come back to it. Vertex form. So what does it start off like? It starts off with something like this. Y equals, let's say, x squared plus 8x minus 3. Sure. That's standard form, not standard form. This is standard form. We're trying to get some vertex form. And vertex form looks like this, like y equals x plus, I think, h squared plus k, something like that. We're going to get this looking like this. And that's the important thing. We have to do something similar to completing the square. So we can even put these together because they're kind of similar. They kind of use the same idea. And what that idea is half of b squared. Half of b squared. And we remember we have a, b, and c. We have ax squared plus bx plus c. So my a in this case is 1, my b is 8, and my c is negative 3. So what I'm going to do here is, let's make this 0. So let's say I have 0 equals x squared plus 8x minus 3. I'm going to add half of b squared to both sides. I'm going to add that to both sides. Why? And because it's going to make factoring it very easy. So half of b squared, I have 8 squared. That's going to be 4 squared. So it's going to be 16. So adding 16 to both sides, 16 equals x squared plus 8x plus 16 minus 3. Let's move this 3 over. Probably should have done that earlier. We have 19 equals x squared plus 8x plus 16. All right. Once we're here, we're in a very good place because we have this half of b squared because I don't know if you remember, we went through this whole ordeal with factoring. And factoring was all about getting things broken apart into the different things. And this is a perfect square. So remember we had m and p. M times p and m plus p equals a times c, and that equals b. Luckily now, our m and p and a and b, instead of m and p, we can just do 2 m's. Because to add the, I get 4 and 4. So having this perfect square added in cleans this up so that no matter what, this factors into x plus half of b squared. And remember, this square does not just go to this and this. It makes 2 versions. We don't square each individual. So don't ask, where did this go? We're going to factor it into this. So we have 19 equals x plus 4 squared. From here to here, remember, this is x plus 4 times x plus 4. If I FOIL this, I get x squared plus 4x plus 4x plus 16, x squared plus 8x plus 16. So remember, this gets us to here. We don't just distribute the square to each one of these. So once we get here, I'm going to square root both sides because I have a square I need to get rid of. So I have the square root of 19. There's absolutely nothing I can do with that. And x plus 4. It's actually the plus minus square root of 19. And last, I subtract 4. Clean up, so I just have an x. So I have x equals negative 4 plus minus the square root of 19. There's nothing I could take out of here. There's nothing I can simplify. So I get here, this is two answers technically. If you put this in your calculator, you would get second square root 19. So this is like about 4.35. So if I add -4 to this, I get a very small decimal point, -0.35. If I'm subtracting, I get -8.35. So this is a perfect answer. This has all the details of this crazy decimal. But if you put it in your calculator, you get something different. Oh wait, I completed the square. That's okay. Because we still end up here in completing the square, but if we want to do vertex form, we'll take this step and bring it down here. So I'll switch it around. X plus 4 squared equals 19. So this is our vertex form. Portion. And what we're going to do with vertex form is we don't like having this 19 over here. Quadratics are sort of at a resting place when this is going to be a 0. So we need to move that 19 back over. And we get x plus 4 squared minus 19 equals 0. This is now in vertex form. And what we see here is that when we graph this, we move it left 4. Remember, this is going to give us our opposite direction. And we're going to go down 19. So my vertex should be at left 4 is going to be -4, -19. So let's see. Our original equation was x squared plus 8x minus 3. X squared plus 8x minus 3. I'll go to my table. This is probably your best way to find your vertex. Go to the table. And right here, there's -4, -19. If you can't see it, you'll just have to trust me. So once again, vertex form / completing the square. It's very similar, the first couple things you do. We have this, and we're going to add this half of b squared because this guarantees we get a very clean little factor. So this time it was 16. We moved that 3 over. This factored into this. If we wanted vertex form, we came down here. If we wanted to complete the square, we kept going, kept solving until we got here. That's vertex form, completing the square. That's just for honors. On-level people, don't freak out. We didn't learn this. All right, what other things I saw? I'm just going to ignore most of these. Can we go over factoring? Yes, we'll go over factoring. That's a great one. There's going to be a graph in the exam. How do you find the inverse of matrices? Yeah, good question. So let's say we want of 2, 3, 4, and 8. So we have this matrix right here. We can call it A. Doesn't matter. And we're looking for the inverse, also known as A to the -1. That button, that inverse button, is right here, the button you press for matrix. Yeah, you can't see that. So I'm going to put it in. To put a matrix in your calculator, we need to go second matrix, then over to edit. We want 2 rows, 2 columns, 2, 3, 4, and 8. Put them in. 2 rows, 2 columns. We'll quit. Second matrix A. It'll give us our little matrix. And then all we do to get an inverse is we press the inverse button after A and press enter. Math frac will give us fractions. And so our inverse is going to be 2, -1, -3/4, and 1/2. As you can see, these are different. it's not sort of a nice little pattern. It's really complicated how we get this. We talked about it very briefly. But on some of these, on some of the multiple choice questions, I have wrong answers. Like this. I did one, I think it was -2, -3, -4, -8. Because some people may think, oh, inverse will just make them all negative. Or maybe 1/2, 1/4, 1/3, 1/8. That's another way I could have tricked you. But they don't really match each other. There's no pattern like this one has to be this one or half of this one. It just happens this way. You can look up the equation. We talked about the equation very briefly. But we find the inverse just by plugging in our calculator and using the inverse button. Some don't have an inverse. For example, let's call this B. About 2, 4, 8, and 1. Looks similar. But the thing about this is the determinant of B is going to equal 0. And if it has a determinant of 0, it doesn't have an inverse. So we can try putting this in and showing what you'd get. Matrix, edit, 2, 8, 1, 4. We'll quit. Matrix, B, inverse. And it says, uh-oh, singular mat. That's what your calculator says. That means it doesn't have an inverse. If you do that on the exam, then I can't tell you what's right or wrong, but you know that some have inverses. For example, this one is this. I try to trick you with wrong stuff like this, wrong stuff like this, and then some don't have it. So you try it, you get singular mat. That means it does not have an inverse. Matrices, inverses, all the things you need to know. Let's see what else people are asking. Scatter plots. Is vertex form going to be multiple choice? Short answer. I think vertex form is multiple choice. Doesn't vertex form stop right for square rooting stuff? Yes. Yes. Okay, agreed. I don't know what all these things are saying, so I'm going to ignore those. Can we go over what to do when a doesn't equal 1? Oh, yes. So let's do a factoring where a is not equal to 1, because that's on everybody's. Spoiler alert. When a doesn't equal 1, let's do that. 2x squared. Do I want plus? No, I want, yeah, do I want plus 5 or minus 5? Plus 5, x minus 25. So let's just factor this. Let's factor this one. This is great. Just looking at everyone. It's like talking in the chat, just like talking in class. So we're going to factor this. We have a, b, and c. Those are our coefficients. 2, 5, and negative 25. So remember, factor, we want to get 2 parentheses filled with things. We don't need to equal anything. And if you don't see an equals 0, that means we don't have to have an x equals something. So we have this, and we need some secondary stuff. After we get this, we need a times c. So it's going to be negative 50. And then b again is 5. You don't have to write b again, but when I do this, I'd like to think about it because these are 2 numbers we're going to use to match. We need an m and a p, m times p, and then an m plus p. When I look at this, there's nothing that jumps out to me that works. So I'll just start with things that multiply to negative 50. We have negative 1 and 50. When you add those together, you don't get 5. So let's do 2. Negative 2 and 25, we don't get 5. 10 and 5 multiply to 50, so one of them has to be negative. We'll make 5 negative. So these multiply together to get negative 50, but only this one works to add to b. So we'll make these our m and p. It does not matter which one is m and which one's p. What we're doing is we're taking this 5x and expanding it. We're making it more complicated. So that way we can factor out of something of the first two and then factor out the next two. Because right now, only this 5 and this 25 have something in common, and we can't do anything with that. So I have 2x squared. Instead of 5x, I'm going to do plus 10x minus 5x. 1 second. Minus 25. So I took this and made it more complicated. I made it more complicated because now I can factor out of here and here as a little pair. So I'm just going to rewrite it with my parentheses. I'm not changing anything. Plus negative 5x minus 25. That's a big tricky thing right there to make sure you don't forget the plus sign. I have 2x squared plus 10x. And so I have to think, what is the greatest common factor of all of this? Not just the 2 and the 10, but the x squared and the x. So I have an x and a 2 in common. So I'm going to take 2x from both of these. So I've left with just an x plus 5. If I distributed this 2x back in, I'd get back here. That's how we're doing. We're reverse distributing. And then I have a negative 5 out of here, x plus 5. Remember that the most important thing is these things end up being the same. If they're not the same, then go back here, make sure you set this up right. But these are the same. So I have 1 from x plus 5, and then we're going to have 1 that's going to come from these numbers, these outside numbers. So one thing's going to be 2x minus 5. Those are my outside numbers. Then my last one's going to be x plus 5. So once again, we started here. I went through all this work just to figure out what is the right way to split this up. I could have split it up like this, but I couldn't factor then. But with this, with 10 to negative 5, I can split it up here, factor out, and solve. If you are unsure, we can just FOIL this back together. 2x squared plus 10x minus 5x minus 25 plus 5x minus 25. And it works. So we get an answer, we can always FOIL it. So if this was even a multiple choice problem, we could figure out which one was correct if we FOILed all of our options. So we can figure this out even if we don't know on multiple choice. And on a free response, we can do this or hope and pray that we remember one day what to do. Vocab you should study. That would be from 09. We had the 7 words. I went over right at the very beginning of this. You can scroll back. Sounded like a darn Lifetime movie. LOL. Everett, why you do that? I don't understand this stuff. Whatever. There are answers in the back of the book for odd questions. Yes, I agree with this. For the study guide review questions in the book, are there an answer sheet? There should be one on Schoology under everybody's thing, under everyone's course. So let me check if honors has it and on level. I think I put up for both. It's just a study guide and review answers. Check those. If not, all right. Mr. Goodroe, were you Ricky or Bobby? I don't know what we're talking about. I was doing music that whole time. Slater.com might have the answers. Yes, they do. Wait, what do we do when A equals 1 again? Okay, so if A did equal 1 in this universe, we'd take this M and P, and we'd go straight to, all right, if A equals 1, we do X plus M, X plus P. So if A equals 1, we can jump straight to this. If A is not 1, we have to go through this nonsense. What page is the study guide thing again? If you just look on Schoology, they'll have the questions too. Wait, I'm really confused. Can I do this in my calc? The factoring, you cannot factor in your calculator, I believe. Division with imaginary numbers. We'll do that one real quick. So division with imaginary numbers is more like simplification with imaginary numbers. Let's say we have 4i over 2 plus 3i. And I'll say something like simplify. Something like simplify, we just have to use our parentheses. So we'll come in our calculator, go parentheses 4i divided by parentheses 2 plus 3i. Easy as that. If we don't, we'll do math frac. If we don't do parentheses here and here, we're going to get a different answer. Make sure you know how to turn this into a fraction in your calculator. Press math and then frac. You don't have to scroll anywhere. You get this. This is a simplified version because I is no longer, we can't have that in the denominator. Can't keep in the denominator. So we put in our calculator, it does this for us. Yes, if you have questions, you can also go back and look. This is rewindable. Now here's a cool trick you can do at home. I don't understand these memes. What page is the study guide thing? Wait, what's the final answer to the question you just did? The factoring one. The factoring one, final answer is this right here. 2x minus 5, x plus 5. And then we can check it by foiling it again. Everybody be nice. It is just YouTube, and it's just a math exam. So a couple things we talked about, things we went over. Now I'm looking on the floor. We have a probability question we talked about. We talked about piecewise functions. It's sort of the trick to know that. A lot of this, even if you don't know it, there's tricks you can learn to make sure you figure out the right answer. You have matrices. This is sort of a good example of when to know you have a good error and a bad error. Sort of an error that tells you, hey, this doesn't work. That'll be one of your options. It's rational, irrational. I say it's a whole natural integer. Yes. Know the classification numbers. If you see a square root, it's a good chance it's an irrational number. So square root of 2 or square root of 3. I may do something tricky like square root of 4. That's just 2. So these are irrational. This is rational. All of these are real. It's also an integer, whole, and natural, but that's another story. So if you see square roots, it's irrational. For I do the second, then decimal. For I do second and decimal point, agreed. Everything ration, irrational, whole, natural, etc. Did we already go over linear optimization? Yes, we did one quick one. We did a linear optimization where we had these three things, and we graphed them first. We did them by hand because it's going to be simple enough where we look at the slope and the intercept, and we can graph that and see where it intersects. And we don't have to calculate this. That way we plug it in, we get our answer. So we did a linear optimization, and you can do this in your calculator, but I just think that's one more step to try to figure this out, see where this is, do second, trace, jump around. I don't think it's worth your time. I would say honors. Make sure you know bounded and unbounded. The only difference is when we get this and we get this, what we have to do is we have to test a point in here to see if it's bigger or smaller. So I'll do a little example of that. So this is a quick unbounded. You've found your data points. Let's say you found one value, f of x comma y, gave you 10, and then the other gave you -7. So what we're going to do when it's unbounded is we're going to see, this is for honors, unbounded. We need to see if we have a number bigger than 10 or smaller than -7. Bigger than 10 means we have a minimum, because then it'll keep going up. It'll keep getting bigger and bigger. If it's smaller than -7, we have a maximum. So we need to test points in there, in here, and get something smaller than this or bigger than this. If it's in between, we got to keep trying. So we're looking for bigger than one or smaller than the other. What is point slope used for again? Dilations? No dilations. Someone just put, how do we solve 2 times 3 plus 4 minus 1? I don't know. Put in a calculator. Scatter plots. So we have scatter plots. You have a graph, let's say, and that has a trend line. That has a direction it's going. And you can see these points are kind of generally going up. So it's got a positive slope. And we have different kinds of correlation. We have strong correlations and weak correlations. The interesting thing is, here's a little pro tip, that if, let's say I was giving you a graph and it had some points over here too. You could make the case that this has a positive correlation. So it'd probably be maybe weak positive. But if I'm giving you a test and there's an objective answer, it might be hard to give you one with weak. So if you see one tomorrow, it's going to be strong. That's just your little tip. It's going to be strong, positive or negative. If it's negative, that means it's going down. It's got a negative slope. So it's going to be strong, positive or weak, negative, and we have regular correlation. When it says describe, that's all I want. Tell me positive, strong, weak, strong correlation. How do you solve x divided by 3 plus x over 16 equals 3/4? Yeah, we didn't do that yet, so I don't know. Point slope form, that is what we use when we have a point and a slope and we want an equation. So we're going to write an equation in slope intercept. And so my slope, for example, is 3/4, and my point is 2, -1. Point slope we'll use right here for finding this equation. Y minus y1, so we plus 1 equals 3/4 x minus x1. Y plus 1 equals 3/4 minus 6/4. 3/4 x minus 1 or minus 4/4. I'm going to get y equals 3/4 x minus 10/4 is 5/2. So that is an equation where if I gave you a point and a slope, we'll put it in point slope form and get an equation. These are going to have like 12 points of your final, these kind of things. So know how to do this. You'll do this like 3 or 4 times. Or no, sorry, 6 times. And hopefully get them all right. You can always check these by taking your point and plugging it in here and seeing if it makes sense. You can say -1 equals 6/4 minus 5/2. which should work. Yep. So anyway, I have 1. We're good. Point slope form is used there. We'll do a couple more minutes of stuff, a couple more questions. You can still, this should be up even afterwards, so you can watch it and get all of your questions answered. Can you do identity matrices? Yes, I can. Identity matrices are easy, very easy. They are the letter I for identity, and they are just something like this. And the way you know, the way you do them, no matter what size you want, they're always going to be square. And they always have 1s going down this column. So this is a, let's just say a 2 by 2 identity matrix. If I wanted even something bigger, like a 4 by 4, I could do something very big. I have 1, 0, 0, 0, 0, 1, 0. So the only rule that you'll need to remember when dealing with identity matrices is that they have 1s going down this diagonal. What these are good for is if I multiply a matrix by this, it doesn't change it at all. It's like multiplying it by 1, and we can get these identity matrices in our calculator. If I go to second math and then second matrix math, down here at the 5th button, I have identity. And it's going to ask for a prompt. And all I do is I give it how many rows and columns I want. So if I want a 3 by 3, I put identity 3, enter, it gives me that. I can get the 4 by 4, and you can see it matches that perfectly. So identity matrix, we know that inverses, when we multiply them together, A times A inverse give us our identity matrix. On level, know this. We can, so if I had, let's take A for example. Remember A was this 2, 3, 4, 8. If I multiply A times second matrix A with the inverse, I'll get an identity matrix, 1, 0, 0, 1. So identity matrices come in there. They just writing them are simple enough. They go by I for identity, and then they're just 1s going down this diagonal. When you multiply inverses together, you get them. All right, let's see what more questions we may have. Can you look up quadratic online? Press F to pay respects. Thank you. Can you do quadratic formula? Yes. Just let me know. Yes, Carson Connolly is offering to plug it in your calculator. That'll be a big help, but I'll talk about it no matter what. Need a little bit more paper. All right. So we had the quadratic formula. This is useful for everybody on level. This is going to be on your test somewhere. I won't tell you where. We had x equals negative b plus minus the square root of b squared minus 4ac all over 2a. What this is our magical little formula to get every answer to a quadratic. And what a quadratic, the answers are, if we look right here, our answers are where it crosses the x-axis. So something like this, it would help me find this point and this point. This also helps us find it when it doesn't actually cross it. If we had a graph like this that never crossed it, it still crosses at a different axis in the imaginary plane. It's complicated, but we still have answers that work for this, even when they don't, when the real solutions don't work. Short answer is put this in your calculator. There's instructions on Schoology, and you can plug that in. But if I gave you something like x squared, how about minus x minus 12 equals 0, we can solve that by having negative negative 1 plus minus the square root of 1 minus 4 negative 12, 1 all over 2 and 1. That's going to be 1 plus minus square root of, let's see, 4 times 12, it's going to be 48. Square root of 48. Oh, no, plus 48, that's going to be 49. Over 2. We get 1 plus minus 7 over 2, also known as 8 over 2 and 6 over 2. So we have 4 and 3. So the quadratic, negative b plus or minus square root, we get our answers. If you have it in your calculator, you get it by pressing program. That's this button right here. You should have one called quad. Oops. Program, quad. And you say A. My A is 1. My B is negative 1. Don't drop those negatives. Negative 12. And I get 4 and negative 3. If you need to put this in your calculator, ask Carson, go on Schoology, you'll get those things. Yes. Nick, go back and look at the completing the square one. Rewind. Triangle area thingy. So let's say we have a triangle at 3, 1. This is honors, by the way. We have a triangle at 3, 1. How about 0, negative 7, and negative 5, 2. These are about right. These are about right. So we have this. Draw a little triangle. It's kind of close to equilateral. But it's not exact, and I didn't mean for it to be exact. But I want to figure out the area of this triangle. This could be a question on there. It will be. And it's not going to say anything about matrices, but it is. You use matrices to solve it. We can't solve this without matrices. So what we're going to do here is actually make a new matrix. Our area is going to equal 1/2 the determinant of these points. 3, 1, 1, 0, negative 7, 1. And what I've done, you see these vertical bars mean the determinant. I put the points x, y, x, y, x, y, and then 1s in this column. So what I'm going to do is go to my calculator. Most of this exam is on your calculator, luckily. I'm going to edit it. I want a 3 by 3, negative 5, 2, 1, 3, 1, 1, 0, negative 7, 1. All right, so I plugged it in under A. I'll quit. There it is. Make sure these sort of match up. We have 1s in this column. We have this. This means I want the determinant. Let's use this one. So I get that DET by going second matrix math. It's the first option. DET, and I'm going to put our A in there. And I get negative 67. So I get 1/2 times negative 67. We're going to turn that into negative 33.5. And then I'm going to turn that into positive 33.5 because we can't have negative area. We can't have negative area. And then lastly, I may have said these are centimeters, these are miles, or maybe even nothing, just units. And so we're going to write here 33.5 units squared because it's an area. Area is always going to be squared. And if I don't give you units, just put units squared. So we have the points. We plug them in here. Column of ones. Determinant. So we take the determinant. That's your first under math, matrix, math menu. And then we get this. Doesn't say matrix in the question, but you do all this and you find your answer. All right, let's see what other questions we have. Welcome, Cam Johnson. To solve system of equations with matrices. Okay, yeah, I'll talk about that real quick. I'm going to make this example up, so it might not work well, but we'll get an answer no matter how clean it is. So we'll assume for a moment we have a system of equations that looks like this. Maybe 2x minus 3y equals 10. And then 4x minus y is, I don't know, negative 8. And we're looking for where these intersect, or if they even do intersect. So we could do a couple things. We could manipulate these into y equals. We could substitute. We could eliminate. But we're going to use matrices. So I have my A matrix, which is going to be my coefficients, 2, -3, 4, and -1. And then my B matrix, which is going to be the stuff on this side of the equation, 10, -8. We have a formula we're going to use, and that's going to be A inverse times B is going to give me my what's called X matrix. That's just going to tell us what our coefficients are, or X, comma Y. So I'll plug these into my calculator. Second matrix. Edit A. I have a 2 by 2, a 2 row by 2 column. Matrix 2, -3, 4, -1. 2 and 1. I have 10 and -8. These two numbers right here. All right, so I will quit and go matrix A inverse times matrix B. And I get, oh, that's fine, some strange decimals, -3.4 and -5.6. And this is our X value, so this is our point, -3.4 comma -5.6. This is where these two lines hit. I can show you on Desmos, or you can try it yourself. But the important thing here is we have A inverse times B. A is our coefficients, B are the other side of the equation. And we get our X comma Y. If we had 3 variables, we'd just make this a bigger matrix, this a little longer, and we'd get 3 answers. So we solve it with this. On level, we'll have this on one of your questions to remind you. Honors, just you need to memorize it. Thank you for the review. Yeah, you're welcome tomorrow. Y'all can look up how to program the equation in calc. It should be one of the first results on Google. Dallas is correct. There's probably a YouTube video. All right, if there's no more questions, I'll probably answer maybe 1 or 2 more. Most importantly, do your best. It's not going to be, I'm not trying to make it impossible, but I'm trying to make it difficult for you if you didn't study, or challenging if you're in honors, to give you some mental stimulation that is, I don't know, pushes you past what you think you can do. Sarah appears to need a charger. I would do that sooner rather than later. I will not have calculators to give out tomorrow, so don't come asking for one. That will be, you'll be unhappy with your result. Also, what was I going to say? I may be hiding from people with their bad questions, but I may also just be in my room. So stop on by, help each other, go in there calm, get a good night's sleep tonight. That's going to be most of your that's gonna do most of your help for you. Partial credit, not on multiple choice, but on the last ones for sure. Especially if you show good work. Maybe if you draw me a picture, I may give you more. Yep. All right, well, I'm going to shut this off, and this will still be up for playback if you need help, but I believe in you guys. You'll do well. All right, have a good rest of your evening.